The objective of this is to create some crimping lugs from cheap copper tubing. And there are several reasons for this. Number one being it's cheaper, obviously. Number two is I don't have a crimping tool, and without a proper crimping tool you wouldn't get a proper bind. It wouldn't really be strong. The other reason also is that the plan came with 10 squared. It runs about 65 amps measured, and well, to get that flexible wire for that small size isn't really available locally. So what I ended up doing is taking what we call rhino cable here. It's a flexible cable, 4 squared, and use all 3/4 4 squared. So what you end up with is 12 squared, which isn't bad. That said, that doesn't really fit any specific lug size. Without a proper crimping tool, that's going to be trouble. So the plan was very simple. Cut some copper tubing, make it shape it up like a lug, put some notches so that it can grab the wire, put some solder in, and well, pretty much then heat shrink it. Finished. Well, hold the drill yet. Got 2 notches. You can bung this in to crimp the wire inside. Ends cleaned up. Just a drilly hole there. 3/16 square with that one. This is for our welding plant. Trying to make this little thing, very small welding plant. Trying to put this in onto our rectifier. So theoretically, this goes in here, or get nailed up, bound up, and pushed in. Right, solder. What's in there? Focus. Right, solder in there. Alright, this is rectifier. Going to put this on our welding plant. Just bolt it up, 3x6 box. Transfer the writings, positive, negative, the 2 sides of the AC coming in. Alright, holes on the sides here. Bring in a cable from here, bring in a cable from there. Have option to come in from here. Get my AC welding, DC welding, all bolted up. Just to get the bolts now. Run these up. This is the finished rectifier here. The rectifier bolted down through here. We got incoming leads from the plant. Alright, this is the ground clamp, positive. This is the negative out on the rectifier, positive out on the rectifier. So we are basically electrode negative. Testing 100 amp according to them. 1200 volts, Chinese, I guess we shall see. To conclude, welding was done and both electrode negative, electrode positive. I'm not really a welder. Yes, it does show a difference. It didn't really help me, but there was some difference in terms of the penetration, as the literature suggests, but it wasn't really that great. I did not actually mic the current with the DC setup to see what the change was, and again that 65 amps was really when it was just on the black cable at that point. So having added about 10 feet on either left side, so about 20 feet of additional cable, I'm sure there's a voltage drop. I'm sure the current is different. I'm sure on the DC, with the resistance that you would get from the heat generated in that diode, it's not just the 0.6 volts that theoretically drop. I would expect lower power flow through the entire system now. Again, it wasn't checked, so I don't know the exact value.